Hi guys, welcome to another episode of MrLopezClasses.com. In this episode, we are going to talk about the head valve's job and the inspection and reparation methods of the head. This is the episode number 2 of the chapter 5. Alright, we are going to repair the head, the procedure to repair the head, and we are going to verify what is the procedure to do the inspection on the head, the different type of inspection methods, and after that we are going to verify how to repair the head. Let me explain something before we continue. This project, the project to repair the head, is very important in marine applications. Why? Because normally in general terms, the marine engines, the enemy of the marine engines is the intrusion of salt water in the engine. The intrusion of salt water in the engine. I am going to explain later the two possibilities for intrusion of salt water inside of the combustion chamber. If in the combustion chamber enter a small amount of coolant, alright, it's not good, of course, it's not good, it's dramatic, but the engine continue running. And what happened outside? Yes, you have white smoke if coolant is entering in the combustion chamber. What is the reason? For what reason? Normally it's because the engine was overheated and the head gasket was blown and the coolant passed into the combustion chamber. In the moment of the explosion, the coolant is evaporated and goes outside like vapor, white smoke. How the coolant enter? Okay, because of the head gasket, or because the head is cracked. Yeah, this is normally the reason, or because on the cylinder, the liner of the cylinder is cracked in some parts and the coolant penetrates the cylinder and enter in the combustion chamber. Those are the possibilities for intrusion of coolant. We are going to study later with more details that situation. In other words, if coolant enter in the combustion chamber, the consequence is white smoke. Of course, after a couple of minutes of operation, the oil becomes milky, like a white color. The compression goes down, the temperature increase, and suddenly later the engine stops. This is when coolant enter in the combustion chamber. The situation is completely different when salt water enter in the combustion chamber. With a small amount of salt water entering in the combustion chamber, immediately the engine lock. The name of that situation is hydro lock. In other words, when salt water enter in the combustion chamber, the situation is catastrophic, and probably the piston expand and the engine block. Why the piston expand? Because the thermal expansion of the aluminum is approximated two times, like the thermal expansion of the steel. Yeah, that's the main reason. That's the answer for the question. Yes, because the different type of materials in the combustion chamber, normally the piston is in aluminum, and the cylinder is in steel, and the thermal expansion of the aluminum is twice. The piston expand and immediately the engine is locked. That situation occurs immediately and a small amount of salt water enter in the combustion chamber. Why not with the coolant? Because the coolant have additives and the coolant have a lubricity. In other words, the coolant is a little oily, and for that reason the engine continues running when the coolant is entering in the combustion chamber. But when salt water enter in the combustion chamber, the engine lock, stop immediately. There are two possibilities. We are going to study later that situation. In other words, the head is critical, and the temperature of the head is critical. For that reason, immediately you remove the head in a diesel engines, you need to verify the condition of the pistons. We are going to talk in this video about that, and we are going to verify what was the problem. Oh, the problem was rich mixture, lean mixture, coolant entering, salt water entering, oil entering in the combustion chamber, or too much fuel. According with the color, according with the situation in each cylinder, immediately you remove the head, it's easy to identify what was the problem, and it's probably possible repair the engine. Yes, in marine application, in some cases, the problem is focused in one cylinder, and yes, it's possible repair that cylinder. It's possible remove the sleeve, the cylinder, replace for a new one, replace the piston, replace the bearings on that cylinder, and repair the head and put in back the head and start the engine again. For that reason, this project, the project of this video, of this episode, is very important. In this video, we are going to learn the procedure to repair the head, the procedure to remove the valves, separate the springs, check if the head is in good condition with the different inspection methods that I am going to explain right now, and repair the head and put back the head with new head gasket and start the engine again. Yes, it's possible fix it an engine working inside of the engine room. You don't need to remove the engine outside of the boat. You can continue working on the engine room, and you can fix it the head, and you can fix it one piston or two piston if it's necessary. All right. For that reason, we are going to follow all the steps in this video in order to do the project of reparation of the head. This video is very important for you, marine technicians, marine engineers, surveyors, managers. Okay, I hope you enjoy this video. The procedure is like this. The first step is we are going to remove the valve cover. Immediately we remove the valve cover, remove the rocker arms train. We are going to remove the rocker arms. Slowly we are going to lose, normally is 4 or 6 bolts in order to keep the train of rocker arms against the valves. Alright, we are going to remove the rocker arms train, and right now, without the rocker arms, the head is free, and we are ready to remove the head bolts. When the head bolts are out, we are ready to install the tool necessary to remove the head, if it's necessary, because the head is too heavy, or if the head is not heavy, we are ready to remove the head by hand. All right. And right now, when you remove the head, the first step is take pictures of the face of the head and take pictures of the cylinders and verify the condition of the cylinders. This is a critical moment when you remove the head. In this moment, in the moment that you remove the head, you can identify what was the problem of the engine. For example, if you found one cylinder full of water or corroded, it's probably because water entered into the cylinder. If the cylinder is full of water, coolant is probably a problem on the head gasket, or probably the head was broken. If you found that corrosion on the cylinder, is because in the cylinder entered salt water. This is not good. Alright, if you found that corrosion, oxidation, is because this is not coolant, is salt water, and the salt water produces that excessive oxidation on the cylinder. Also, you can find one piston broken. One piston broken, that the piston that you have on the screen right now, or you can find one valve bended. Or you can find pieces of metal on the head of the piston, probably because the spring valve was broken, and pieces of metal enter through the intake or through the exhaust cavity and enter in the combustion chamber, and those pieces of metal destroyed the head of the piston. Or other possibility for that head of the piston broken is high temperature in the combustion chamber. High temperature in the combustion chamber is poor mixture. That cylinder was running with no fuel, and the temperature in that cylinder increased past the limit and melted the metals. The melting point of the aluminum is lower than the steel, and the piston is melted, is broken faster than the cylinder liner or the cylinder head. This is the typical consequence, and the head of the piston is broken. It's basically for high temperature. Why? Because the mixture was lean. Alright, this is other consequence. Other situation that you can see immediately you remove the head is if you have black carbon, dry black carbon, is excessive fuel. If you have a excessive black oily deposits, this is excessive of oil. If you found that coolant, this is probably head gasket broken or the head crack. And if you have a corrosion, it's because salt water enter in the combustion chamber. Those situations should be inspected immediately you remove the head. And I recommend, before you send the head to the machine shop, take pictures of both of them in order to clarify problems in the future, alright, with the customer or with the captain if it's necessary. Alright, you remove the head. Right now the head is out, is separated from the block, and you are ready to repair the head. As soon as you have the head separated from the block, right now the head is separated from the block, we are going to verify if the head is completely straight or if the head is bended. In order to verify if the head is straight, we are going to use the metallic ruler that we have on the screen right now. This is a special metallic ruler, completely straight in a special steel, and we are going to put the ruler in the face of the head in order to verify if the clearance in the middle of the head is according with the manufacturer specification of that specific head. We are going to check in two areas. On the face of the head, like the picture that we have right now on the screen, and on the face where the exhaust manifold is bolted, and on the face where the intake manifold is bolted. And we are going to verify if the clearance in the middle with a filler gauge. We are going to introduce the filler gauge in the middle, in between the metallic ruler and the head, and we are going to verify if that tolerance is according with the tolerance recommended or accepted for the manufacturer in the manual. This is an important procedure that immediately you remove the head, you clean the head, you should verify if the head is straight. The process to repair the head is before you start to disassembly the valves. I recommend clean the head with a mineral spirit. Clean the head completely, remove the excess of oil, the excess of carbon deposits, remove the excess of carbon deposits, and prepare the tools recommended in order to compress the spring and separate the valves from the head. There are different types of tools, like the tool that you have on the screen right now, and with those tools we are going to remove, to compress the springs and separate the valves from the head and do the service on the head. Okay, and we are going to remove valve per valve, and at the end we are going to put all the valves organized piston or cylinder by cylinder, organized the valves, the retainers, and the caps of each spring, organized in order to avoid mixed the springs of one cylinder with the springs of other cylinder. I recommend prepare one table like the table that you have on the screen right now, and organize the springs, the caps, the retainers of each cylinder, organized with a label per each cylinder. Right now, the valve, the head is completely free, no valves, and we are going to check with the micrometer the dimensions of the valves. The dimensions of the valves, we are going to check the lateral dimension, the diameter of the sink. We are going to check the total length, and we are going to check the internal diameter of the valve guide. And with that information, and also we are going to check the free length of the spring, and with that information we are going to check, we are going to verify, we are going to do the comparison with the information of the manual. For example, if the springs are a little short than the original length, the spring should be replaced. If the dimensions of the valve are out of the range recommended by the manufacturer, the valves should be replaced, and of course the valve guide, and of course the seals of the valve guide. Those three elements should be replaced. Alright, suppose that you found that the valves should be replaced, and you found that the condition of the valve guides are with relative good condition. In other words, you want to replace only the valves, and we are going to keep the same valve guides. Alright, in that case, you order the valves, and as soon as you receive the new valves, you introduce the valves through the hole of the valve, and you do the lapping procedure. What is the lapping procedure? The lapping procedure consists in set the valve appropriated against the seat of the valves and produce a good seal. How can you do that? In order to do the lapping procedure, I recommend prepare a drill with a hose and an adapter in order to move the valve at high speed against the face of the head, applying in the base of the valve lapping compound. The lapping compound is a sandpaper in cream. You apply the lapping compound in the base, in the face of the valve, and with the drill you pass against and against and again for 4 minutes, 5 minutes, and you clean periodically the valve in order to verify the condition, in order to verify if the seat of the valve is properly seated and if the face of the valve is clean, appropriate. You do that process with each valve, and at the end we put the head with the face of the head up, facing up, and we apply gasoline in each cylinder in order to verify if the gasoline penetrate the valve and pass through the intake port or through the exhaust port. This is the process to verify if the job on the head is appropriate. Okay, once again we are going to repeat. Immediately you remove the valves, and you have the new valves. Before you put the new valves, the idea is lap the valves against the head, and we are going to use the tool that you have on the screen right now, and we are going to use valve lapping compound. And the lapping compound, you can buy the lapping compound in any automotive storage. and is universal. The lapping compound is coming in different grades, exactly the same like the sandpaper, grade 80, 120, exactly the same like the sandpaper. I recommend use a fine lapping compound in order to seat the valves. And when you finish the procedure to seat the valves, you put the valves facing up, and right now with gasoline you can verify if you don't have leaks. After that, we are going to return with the connection of with the installation of the springs again, using the same tools used to remove the springs. We are going to use the same tools, maybe the C-clamp, or maybe the adapter that we prepare for this MTU engine. We are going to compress the spring, and we are going to enter carefully with your hands with no gloves, because it's easy drop those retainers on the bilge of the boat. We are going to introduce the keeper, the retainers, and we are going to release slowly the valve, and right now the valve is ready. After that, with a bronze hammer or plastic hammer, we can punch the valve, the shaft of the valve, and we can verify that the keepers, the retainers, are properly installed. And right now the valve is ready to be installed on the block, again with the appropriate torque. Now we are going to check the different techniques used to inspect the head. Not only the head and block. Those techniques that I am going to explain right now are the same for block, for head, for housing of transmission, for housing of lower units. This is very important in order to verify where is located the crack, and in order to verify if it's possible repair the head. In my opinion, I don't recommend repair the head, especially in diesel engines. You know, the pressures on the combustion chamber is a lot of pressure. If the head is welded, if the head was repaired, you have a problem. I don't recommend. If you have if you found a small crack on the head, I recommend replace the head. Yes, we are going to check right now a couple of techniques to inspect the head. Of course, that procedure, the inspection of the head, should be before you do the job on the head, the lapping, that procedure. This one, the inspection should be before. But I put in the last part of the video for technical purposes, because I think that the method should be, I explained before the components and the procedure, and at the end I prefer explain the techniques to inspect the heads and the techniques to repair the heads, the welding procedure that I don't recommend in marine application. In marine application, replace, always replace, never try to repair, because it's too expensive, and at the end of the day you spend more money and time trying to repair. Replace is better, and remember, the boats are the toys of a rich guy, and you need to keep those toys in perfect conditions. Okay, right now we are going to start with the different techniques used to inspect heads, blocks, and housings. There are two techniques to inspect the head. Depending on the material of the head, we are going to use one or the other procedure. The two techniques are the MagnaFlux or magnetic parts technique. MagnaFlux. That technique is used exclusive for iron heads, steel heads. The MagnaFlux is a technique used in steel heads. And the other technique is the liquid penetrant. The liquid penetrant technique is used for both type of heads, iron heads and aluminum heads. Be careful. never try to use the MagnaFlux technique in aluminum heads. Why? It's simple, because aluminum is not magnetic, and that system works only with magnetic alloys, ferrous alloys. Alright, if the head is in a ferrous alloys, we are going to use MagnaFlux. If the head is aluminum or ferrous alloys, you can use liquid penetrant. The liquid penetrant is a procedure widely used in order to verify cracks. Alright, we are going to start right now to check the procedure to check the liquid penetrant in aluminum heads. The first step is, of course, clean the head properly. Clean the head with degreaser. You can use any type of degreaser, included brake cleaner, in order to remove the grease. The liquid penetrant method consists of three sprays. One spray is the cleaner. The second one is the penetrant, and the third one is the developer. The cleaner, the penetrant, and the developer. And we are going to use each of those in a different step. The first step is use the degreaser. With the degreaser, of course, you remove all the grease in the face of the area that you want to inspect. Alright, immediately the area is completely clean and with no grease, you can spray separated 30 centimeters in a clear pattern, and you can spray the penetrant. You cover the penetrant and you let approximated 1 hour, 2 hours that the penetrant penetrate properly on the cracks. After that, after 2 hours, you clean the excess of a penetrant that you added on the head with a paper, with an absorber clean paper, and you apply the developer. The developer should be applied in the same way like the penetrant, and you wait for about 20 minutes, and immediately the concentration of a color, red color or green color, is concentrated in the area where the crack is produced, and it's easy identify where was the crack. Right now, you can take a decision if you repair the head or if you replace the head. In marine applications, never try to repair a head, especially in diesel engines. In marine applications, I don't recommend repair a head. It's more expensive repair the head because probably in 6 months you have the same problem again, right? Always replace the head for a new one. If you found a crack, replace the head for a new one. There are techniques used to repair the head. We are going to talk later about those procedures. Okay, this is the procedure used with a liquid penetrant, and it's very common used. Don't forget the procedure. Clean the area properly, remove the grease, debris. After that, when the area is completely dry and clean, apply the penetrant. Wait for a couple of hours, remove the excess of penetrant, and apply the developer. And once the developer clear the crack, you can take a decision if you repair or you replace the head. The second technique is the MagnaFlux. The MagnaFlux is a wonderful technique. That technique should be used exclusive in ferrous heads, in ferrous alloys. With this technique, you can verify cracks not only on the heads, on the block, on the housing of transmissions, in the housing of lower units. you can use those techniques, liquid penetrant and magnaflux, in order to verify different elements, not necessarily heads and blocks. All right. The magnaflux consists of one electromagnet, like the electromagnet that you have on the screen right now. This electromagnet normally should be connected to a source of power AC, not DC. The coil should be powered with an AC source of power. Be careful, never connect with DC. And immediately you connect the source of power to the electromagnet become a magnet. One end become positive and the other end become negative. Okay, and now you can add it in the area where you want to inspect. You can add it powder of iron, powder of a ferrous alloy with different colors. You can buy that powder of iron with the different colors. The powder of iron red color, the powder of iron green color, the powder of iron orange, or you can create the powder with the file. With the file, you collect the powder, and you added the colorant that you use in your home, in the kitchen, to prepare food. You added the colorant that you wanted, green, orange, red, and right now the iron powder is with color. Okay, you added the powder in the area that you have suspicion that you have a crack, and after that, with the electromagnet with power, you put the electromagnet in different directions until you verify that the powders in color is concentrated in the area where the crack is produced. Yeah, the pieces of iron, the powder, is now accumulated on the crack, and you can see easily where is located the crack. This is an excellent method for ferrous alloys elements, for heads or blocks or housings in a ferrous alloys, cast iron or steel, both of them. In aluminum, this technique is not possible because aluminum is not a magnetic material. All right. Right now, with the crack, you can take a decision. You can verify if the element could be replaced or repaired. And this is the procedure to do the inspections on the heads. There are two techniques. It's a liquid penetrant and magnaflux.